Hi everyone. So last time we learned sample space, some terminologies, that is sample space and the generic element omega in sample space is a outcome, and event A and a complement of event A and the union of two sets or two events, intersection of two sets, set differences and the inclusion, set inclusion and the null set, and the whole space, which is true event, null event and true event. Now this time I will start by definition of monotone increasing, where we define monotone increasing set as, for example, if we start with the smallest set A1, then A2 it includes that A1, then A3 includes both, and in this case we define limit of AN as union of AI. Similarly, we can define monotone decreasing as, so A1 is a whole bigger set that includes a smaller set A2, and the A3 is also inside of A2. It goes this way. To give an example, so let's say let's take A1 as interval 0, 1 including 0 and excluding 1, A2 as 0 interval 0 from 0 to 1 over 2 including 0 excluding 1 over 2. It goes this way. In this case we see clearly that A1 includes A2 and it goes this way. So the intersection of AI is going to be 0, 0, just element 0. So now for this section 1.3, we assign real number P of A to every event A, which we call that probability of A. To define probability distribution or probability measure, we need three axioms. The first thing is probability of A is going to be a non-negative number for every event A, and the probability of whole space is going to be 1, and the probability of disjoint probability of union of disjoint sets AI, we can write it as sum of the probability of AIs. Now how do we read, how to interpret probability of A? There are two common interpretations. The first one is frequencies and second one degrees of beliefs. In the frequency interpretation, probability of A is a long run proportion of times A that's is true in repetitions. So, and the degree of belief interpretation is that probability of A measures an observer's strength of belief that A is true. No matter what, we need axioms 1 to 3 to hold. So the difference in interpretation, we will leave this until chapter 11. So we can focus on deriving some properties using axioms. The first thing is probability of null set is 0. Why? Because probability of whole space is 1. That means, and the complement of this is going to be a null set, so nothing happens, so it is 1. So if A event A is inside of B, that shows that probability of B is more likely to happen. That's why it's higher than probability of A. And we know probability of whole sample space is 1. That's why it is that the probability of A is between 0 and 1. Similarly, we can derive two disjoint set. If the A and B are disjoint, then we can write probability A union B as probability A plus probability B. So we will use this property. Now for any event A and B, we can write this as union of three disjoint sets here in the blue, red, and the green. So I wrote here. Now that tells us probability of A union B can be written as probability of A plus probability of B minus probability of A intersection B. As a last thing, so if we have a sequence of events that converge into event A, then we can write probability of the sequence of events AN converge to probability of A. For that part, we can use the axioms and the property 1.1 and the previous lemma to show that probability of AN goes to probability of